Okay, how about now? Let's see, how about now? Can you guys hear me now? I think it's going to go through now. I think what I was missing is forgetting to hit go live, right? Can't go live until you click live. I think I am going through now. Do let me know. Sorry about that. Once again, another hiccup, but I will make sure I go 5 minutes over so we can go ahead and have that hour of office hours. I'm assuming you guys can hear me. Yes, thank you. Thank you, Lyndon. So let's see who is with us today in office hours. I see Subham is here. I see Alicia is here. Maxim is here. Lyndon is here. Welcome, guys. Welcome to WellQuant office hours. Anna is here. Welcome, Anna. Hello, Anna. Thank you for joining. Let's go ahead and sketch out our agenda for today. I'll put a couple of things on the agenda. And it's wrap up the VC mini project Q5, the K-means question. Let's wrap that up. I see Joseph, I see Fabi. Hello guys, welcome to office hours. Let's take care of those, wrap up the VC mini projects so we can get ready and position ourselves for the next mini project next week. Hello Aya, hello Aya. Everything is going fine. I do want to talk about inheritance since we are in the theme of object-oriented programming. Let's talk about inheritance. Inheritance. We learn how to create our own classes, our own custom classes in Python. And while that's great, in reality, you probably won't be creating your own custom classes from scratch. You may not be creating these custom classes from scratch. However, you might very much create a class that builds on top of another class. In fact, if you go on to Unit 2, which I highly recommend that you guys advance to Unit 2, wrap up your work in this unit to move on to Unit 2, we're going to see the concept of inheritance appear. You don't want to create these ML models from scratch. What you'll do instead is you inherit from that template, from that outline, and then you add your modifications. That's the idea of inheritance, so it's important that we understand what is inheritance, because more often than not, you won't be creating things from scratch. You'll be building upon what someone else has created, right? The whole idea of standing on the shoulders of giants, very much so here. So I'll make sure I do talk about that in our agenda. Let's see, I see Kinjal is here. Hello, Kinjal. Hello, Edward. Hello, Khaled. Hello, guys. So welcome to office hours. There is a discussion about private attributes. Someone mentioned yesterday, so we'll talk about private attributes. And I think someone was asking about some time-it, this idea of time-it. Talk a little more about that. Understand what it's how it works. And someone's asking about this idea of this thing about name. Sorry about that, equal to main. Hello, Maxim. Hope you are doing fine today. All right, so do let me know if there are other things to put on the agenda. I do keep track of what we're covering, so make sure that things that get brought up that don't get addressed today get addressed sometime in the future. So with that said, let's move on. I think we finished talking about the distance part of the VC mini project, but I will go ahead and circle that back around. And the whole point here is do not repeat yourself. We have already have methods that find differences of points. So we don't have to recalculate, program how to calculate the difference of points. We can simply rely on what we already created. And that's what we do. We take the difference of our 2 points. We have assigned that to a new point object. Access the x value, the y value square, and then take the square root and return that distance. And then here is the cell that defines a function that the grader will use to assess your answer. So that's what the grader is going to do. It's going to take this function and it's going to run it with your definition of the point class to make sure you get the correct results. And hello, Naya. Welcome to office hours. So any questions about this distance problem before we move on to Q5, this idea of K-means clustering? And I do have a notebook to illustrate this K-means clustering approach. So do let me know if there are any follow-ups. Of the distance question. Okay. Cluster algorithm, please. All right, let's get to this clustering algorithm. All right, so let's talk a little bit about a bit of background of this clustering idea. So let's say you have, in fact, this notebook is the notebook from the Unit 2. So it's a Unit 2 notebook, but I'm going to use it to explain what's going on for this question. And in fact, what I'll do is after office hours, I will post this on our shared drive. So while you don't have access to it right now, I will make sure you have access to it later on our shared drive so you can download it and upload it to your pod. So I will go and post this after the fact. And what we want to do is we want to create clusters or groups in our data set. So what I have here is a set of points, and I want to define 3 groups in this data set. Define 3 clusters or groups in this data set. So what I'm going to do is I'm going to randomly pick 3 starting points in this data set, in this space where my points exist. And then what I'm going to do is I'm going to take every point and I'm going to ask, which of these stars are you closest to? Are you closer to the yellow, the purple, or this green color? All right, someone's saying there are others waiting on the other link. Let's see. Let me go ahead and investigate that. Might explain the low numbers than usual. Sorry about that. Thank you for bringing that up, Tom. I think the same link, the same link should work out. If you refresh the link we provide, it should take you to this stream. But I might be wrong. I think if you refresh, it should take you to the same stream. In fact, I'm going to go to, what I'll do here, just to convince myself, I will go to our pod and go to video links, and 12, open up a new tab, and I'm going to start seeing myself. Yes, so I do see myself there. I think it might take a while to go through. Yes, that's the one in our email. Okay. So what I'm going to do is I'm going to assign every point to a cluster. Assign every point to a cluster. So that's what I do there with this step. So notice I've assigned all my points to a cluster: yellow, purple, and green. Now notice that these stars, they're really meant to represent the center of a cluster. However, they are no longer at the center of our cluster. So what we got to do next, or what the algorithm does next, is going to relocate the center of the cluster based upon the points that make up the cluster. In other words, it's going to calculate the average x coordinate and the average y coordinate of all the points in yellow, and that's the new centroid of the cluster. Do same thing for the green and the purple. Find the average x and y coordinate of the green cluster, and that's the new location of the centroid. And this is called the k-means algorithm. K because there you have k clusters, and you're going to calculate the mean of the x and y coordinates to define what is the new location of the centroid of our cluster. And that's what we do in this step there. Notice we shifted the positions. In fact, I'll go move back there. We can kind of guess that the center mass is right there. This one will probably move there, and this one will probably move right there. We have the general feel for it. Any questions so far? Okay, so then now we repeat the allocation process. We go through the entire data set and we ask, which cluster should you be assigned to, given the fact that the centroid has shifted, this center mark has shifted. So we do the reassignment. So some things change, and now that there are different members of the cluster, then we update the centroid of the cluster. That's what we do there, and we repeat this, so forth, and so we repeat this process. And finally, eventually, we will converge to a static state where the cluster definitions no longer change. Now my question to you is, if we were to view this as using object-oriented programming, what do you think are two pieces of data that we should associate for every cluster? Let's think of defining a cluster class. What are some attributes that our cluster should have? Actually, what pieces of data should each cluster have? What are your thoughts? Let me go ahead and connect myself by Ethernet. I think that would help out my connection. Hold on. Yeah, connect. Okay, hopefully that will improve my connection. All right, so I see Jeff is saying points in the cluster and centroid values. Correct. We can think of every cluster as being defined by two pieces of data: the centroid and the points that belong to the cluster. And so when we flesh out our class, we'll make sure we have those two pieces of data. So let's go ahead and flesh this out. Let me blow this, increase my screen just a bit. It's a little easier to read. So now if we look at the initialization method, what we do, it accepts two pieces of data, x and y, and it represents the center of the cluster via a point object. That makes sense because a point object stores the x and the y and allows us to do arithmetic on those points. So it makes sense we store the cluster, the center of the cluster, via a point object. And now we want to store all the points that belong to a cluster. And so we got to choose a data structure to hold all the points of our cluster. Any suggestions on a good data structure to use to store the points that belong to our cluster? So let me look at the question here in the chat. The cluster requires a mean and 3 initial points. Not necessarily. No, the answer is no. What we have here is 3 distinct clusters. However, every cluster has 2 pieces of data associated with it, which is the center and the points that belong to the cluster. It just so happens in this case here, we have 3 clusters. Yeah, we're going to use a list. Let's use a list to store all the points that belong in a cluster. So we're defining a class for one cluster. And you can think of, now we have a class of one cluster, then we can create multiple cluster objects from that class definition. So the 2 pieces of data that each cluster should have, it's its center and the points, and we're going to use a list to store those. We're going to talk about the methods that each cluster requires, and that's where we talk about calculating the mean. So we're going to hold off on that thought just in a bit. So now we're ready to talk about what are the attributes of our cluster. Sorry, not the attributes, the methods of our cluster. So we define there, so we have this update method. And what we want to do in this update method is, what we want to do is let's use all the points that are in a cluster to find the centroid, center, and reset the points in our list. So, in other words, given the list of points, how do we go about calculating the center of all those points? So roughly speaking, what should be our outline here? I want to calculate the center based upon all my points. So not necessarily, I'm not looking for code here, I'm looking for a general strategy. How would you go about doing that? I want to find the center of all my points. Welcome, Daniel, to Office Hours. Look for the mean. Yeah, we want to look for the mean of all the x's and all the y's. Exactly, and we have the list of all the points. So now, of the x's and the y's, exactly. So we can say xc, and we have to do an iteration, so we're going to use a for loop. So we can say for point in self.points. That's going to iterate through all the points of our cluster. And since we have point objects, I can say point.x. And this here will give me a list of all the x coordinates of my points. And since I want to find the average, I got to sum them all up. So I'm going to use the sum method. And then I'm going to divide by how many points I have. The number of points I have is just the length of self.points. And that will calculate the average x value of all my points that belong to a cluster. So now I can go ahead and copy this, paste it, and do the same thing, but for y of c. And just change x to y. Any questions of the code I've written so far, what we've done so far? Yeah, so exactly, that would be the sum of x over the length of x. Because what I'm doing here is I'm iterating through all the points. Why to put sum of it? Because this here is going to retrieve, this here is a list of all the x coordinates. And this right here is a list of all the y coordinates. And we sum them all up. I see that Tom has a different approach. In fact, I was going to talk about maybe a different way to go about this. So do share your solution. Let's see if there was what I was thinking about an alternative here. So the reason why we're doing sum is, remember, this here is creating a list of all the x coordinates of all the points in our cluster. And since we're going to find the average, we sum them all up and we divide by how many we have. We do it for x and we do it for y. And once we have the new x and y, what we do is we say self, we're going to update our center attribute. So we can say self.center is equal to point xc and yc. So this right here updates the center of our cluster. And the next thing we do is we got to reset the points in our list. So in other words, we've got to set self.points back to an empty list. So Tom, let's go to, can you share your approach? Kind of curious to see what it is. Maybe I missed it. I don't think I saw it here in the chat, but do share your approach because we can go ahead and do it differently. But this should work out. Not to put you on the spot, but okay, so I'm going to show you an alternative one. Maybe this is what Tom has. Problem cutting pasting. So remember, we have a list of point objects. I'm going to define a new method. I'm going to call it def update alt for alternative, just so we can have the other one side by side. Since we have self.points is a list of points, we can say, yeah, it's more efficient to calculate the in a single loop. So we could say sum and say self.points. And we can call this points sum. This here returns, this should here return, I think it always tries to initialize to 0. I have to double check the syntax. But we could have, the other thing we could have done here is we could have referenced, we could have done something like this. We could have said, oh, sorry, I won't let you paste it. That's fine. We could say for point in self.points, and then accessed point x and point y called reduce. Remember we learned about reduce yesterday? You can say, I think this should also work out. Call this coords. Ah, I see what you did there. I actually like that approach. That seems to be simpler there. Let's examine that. We have x, and let's see, length of self dot centered x, length of self dot points, and let's see. And where did you define x and y? But anyways, in this approach here, this would have also worked. And this would get a tuple of the medium x and the mean y, mean x, mean y. I think this also works here. I could say point sum is equal to sum of self dot points. And then I can divide by, or I can multiply this by 1 over length of self dot points. Because I've defined what does it mean to sum points, what does it mean to divide, multiply by a number. So I think this can also work out as well, an alternative. So yeah, so there's several points about it, several ways to go about it, doing it. Play around with it. But the nature is calculate the average XC and the average YC. You can probably, this year we do it in 2 different for loops, which is okay since they're both order n, but you can probably do it all in one for loop.
Yeah, the stuff that we talked about before.
Okay, any questions people have before we move on to the add point method? Okay. All right, let's go ahead and talk about this add point method. So for a cluster, we got to have a way to update its coordinate and empty out its list, which we defined here. The next thing we have to define is how we add points. So what's going to happen is we got to have a mechanism, we have a method, so we can add what points belong to our cluster object. So simply what we got to do is add the point to the list. Someone's saying they missed office hours 11, they cannot find in the playlist. I can make sure, I may have forgotten to add it to the playlist, but it should be there. I can double check later. Add the point to the list. So we know how to add things to lists. Can people hear me? I see someone saying that they don't have sound. I'll make sure that, yeah, okay. So I think, Tom, I think that's something wrong with you, something on your end. All right, thank you guys for the confirmations. Looks like something is wrong on Tom's end. But thank you for bringing it up because I want to make sure it wasn't a pervasive problem. All right, so we can do self points dot append point. So now we have the 2 methods that are required for our point object. One of which will find the new coordinate and empty out the list, and one that will add a point to the list. So now we are good to go. Now we're good to go to define this compute results function. All right, so let's go ahead and examine what we're doing in this function. So I'm going to make good sense of what we need to fill out here. This function will accept a list of points, a list of coordinates to construct point objects. So the first thing it does, it constructs a list of all the points that we're going to examine. So this here is the list of all the points in our data set. So what I'm saying is, why are we setting the points with an empty list? The reason we're doing this is because if we look at the algorithm, is that once we assign all the points to a cluster, the next step is we update its coordinate, its center, and then we repeat the process of reassigning points to the cluster given the new location of the centroid. So that reallocation process, in order for us to do it, we have to empty out the points that belong to the cluster. And that is why we go here, and this creates the empty out our list. So that's what we actually want that property. So then we can do another iteration where we do the reassignment, assign the points that belong to the cluster. Okay. So let's move on. So we have our list of points. We define two clusters. We're only going to use two clusters here. And notice there are two distinct cluster objects, A and B. And we have AO. These are all, we're going to fill in this list, empty list here. We're going to iterate through 10,000 times, 10,000 iterations of this algorithm. And what we do is we go through every point for point and points. We are going to check which cluster is it closest to. That's why we're using the distance method of our point object. So we take the point, we say, which center are you closest to? Let's see. So we are checking between the two centers which cluster is it closest to. So if our point is closest to cluster A, then that means we're going to add that point to cluster A. And remember, we have a method that we've defined to add points to clusters. So we do self, we say A dot add, what is it called? Add point. We add the point. However, if it's not the case that the point is closest to A but is closer to B, then that means we add that point not to cluster A but to cluster B. And then what we do next, and let me know if there's any questions right now, but this right here is, I'm going to say allocating what cluster should a given point belong in. That's what we're doing there. Allocating of all the points we have, which cluster is it closest to, based upon its current centroid of the two clusters. All right. Then the next thing we do is we check for convergence. In other words, the one with the shortest distance to the two clusters. So now what we're going to do is we're going to check to see if the points in the cluster do not change from before. All right, this is a good question. Why? What does this mean? A old equals an empty list. This here represents the points that belong to cluster A in the previous iteration. This is an iterative algorithm. You apply it multiple times, getting a better and better solution for every run. And the way we're going to check for convergence, that we've converged to the final answer, is we're going to see whether the points in cluster A are the exact same points that it had before. If I notice that all the points that the cluster A had previous iteration, the previous round, are the same at this past round, then nothing changed. The algorithm has converged. And we are going to use, this is initializing, we are initializing the points that belong to cluster A at the previous run. So we initialize it as an empty list. But we will change what A old is after every pass of our iteration. In fact, that's what we do here. We are checking, we check whether the points that cluster A had in the previous round are exactly the same as this current round. Because if it is, then the algorithm has converged, so we break. Break is a way we can stop our for loop. Exit, leave prematurely. Let me know if there are any questions at this point here. All right. So now what we do is we're going to update what A old should be. So A old for the next round will be the points that exist in our cluster for this round. So what we're going to assign A old to be is the points that belong to the cluster A for this round that we just finished. So what should we assign it to? So I'm going to say we have not mentioned distance anywhere, but we are using it right here. Notice here we are checking, we are calculating the distance between the point to the center of the cluster. And remember that the center of our cluster is a point object. It's a point object. So that's where we're calculating the distance right there. Let me know if that answers your question, Kinjal. Yes, correct, Jeff, exactly. A old for the next round will be A points. Exactly. And then afterwards, we update A and B. So in other words, we empty out their lists. We empty out the lists. So then we can go another round of this algorithm. Right, what happens? We do another round of the algorithm. And what do? We iterate through every point. We check which centroid is it closest to, do the assignment. Oh, you're closest to A, you go to A. You're closest to B, you go to B. You're closer to A, you go to A, and so forth. And then we say, okay, let's see the members of A, the points that belong in A. Are you the same as before? Oh, you're not, you haven't converged. Repeat the process again. Update the centroids, empty out the lists, and repeat again. Any questions so far? We're almost at the end here. We got to fix this return. But any questions right now? If you can mention a couple of applications, it would be interesting. Yeah, I can talk about that. So in reality, you would not program your own k-means clustering algorithm. The reason why you won't do that is because in Unit 2, you will learn about scikit-learn, which is the Python package for machine learning. And what it does, it implements an object-oriented programming paradigm. So it offers you a class, and you create objects of that class. And for example, this is a notebook from the ML. I will post it on the shared drive so you do have access to it. I'll just give you a little sneak preview to Unit 2 if you get to advance. And the situation where k-means clustering can be used is perhaps market segmentation. Perhaps you have a data set. And we just have two axes here. And we have, you think of each point represents our customers. Maybe one axis is age, the other one is income. So we have a data set of our customers, and we have two pieces of information, their age and their income. If I want to understand the groups that exist in my data set, what I'm going to do is I'm going to run this k-means algorithm. And what I'll probably find out is that I can break up my customer base into two clusters. And what I can examine from these two clusters is the centroid of them. So then maybe I can use this information in how I target ads to them. Given the fact that I've identified two clusters of my customer base, and one cluster tends to skew younger but don't make as much money, while the other cluster tends to skew older and make more money. And maybe I can use that information to drive how I advertise to these two groups. It's a common application of using k-means in the real world. However, you wouldn't program your own k-means class as we did here. This is more of an exercise to understand the importance of object-oriented programming. What you instead do is use the Python package scikit-learn, and use the k-means class. Okay, so we're almost done with this question, but let's look at what it says here. Once this is done, let's see where I'm looking at. The return value should be the two centers of the clusters by the greatest x value. Please return these lists as a numerical tuple, x1, y1, x2, y2. Someone is asking, is the implementation of more dimensional k-means clustering way more complicated? The answer is yes. It's going to take longer to run the algorithm when you have more dimensions. However, as you'll learn in Unit 2, one thing you can do is you can run your data through a step that's going to reduce the dimensions of your data. So your high dimensional data, you run it through something like PCA. And this is something you'll learn about in Unit 2 if you do advance, which I highly encourage you do. Then you can reduce the number of dimensions. Maybe this has 1,000 dimensions, and you reduce it down to, let's say, 20. And then you can apply k-means. So yes, the more dimensions, it's going to take longer to train, longer to run. So maybe you should apply a dimensionality reduction technique right before, so your data is more manageable. You will learn this in Unit 2. Okay, so let's go and figure out how we're going to report our answer. If we look at what it says return as a list of tuples of x1, y1, x2, y2 with the greatest x1 in front. So in other words, what I could do is I can say return, I can say a.x, a.y, b.x, b.y. However, this here isn't guaranteed. There's no guarantee that ax is greater than bx. So what I have to do is I got to sort this list here. I've got to sort this list. So what I could do is I can call the sorted function. And the sorted function by default sorts it by reverse order, so I can say reverse equals true. It's going to sort it, by default, it's going to sort from lowest to greatest. I went to reverse that from descending order as opposed to ascending order. So make sure I get everything. Extra bracket there. So this creates ax, the y and the x and the y, the x and the y. But then I sort it, it's going to sort from reverse order. So the greater x will be first, and then the other one. Let me just prove that to myself. Let's test it out. I can create my answer right here. I can say 1 and 2, 2 and 3 and 4. So let's go ahead and call sorted my ans and say reverse equals true. And that worked out. That worked out. All right, any questions people have at the moment? Okay. So we got more time in office hours. So let's go ahead and talk about, let's see, I'm going to ask about private methods. How do you make, private attributes? And the way you would define private attributes in Python is very much like we did for private methods. They'd have 2 underscores. So I can say my class here. Shouldn't it be yes, correct. Thank you, Leonce. That is correct. It's a center dot x. Yeah, because the cluster doesn't have an attribute x and y, but the point of the cluster does. So thank you for pointing that out. Thank you. That should work out. Yes, you are correct. Thank you once again. I see someone put in the chat here. Quick, maybe obvious question. Does all submissions completed by December 4 mean a score for each mini project question? Does all submissions completed by mean a score for each mini? Yes, you need to have a score to pass this course, to get credit for this course. You have to score greater than 0 on all the questions by the deadline.
We just bought new batteries for the scale.
And if you're looking for the honors with distinction, it is the average across all the questions of the mini project. All questions of the course. And that'd be greater than 0.9 or greater. All right, so let's go here. So let's say I pass 2 arguments, and I say, if I use double or underscore, that's going to create private methods. Private attributes, sorry. And these are private. Okay, and let me just prove it to myself. My class is equal to my class 1 and 2, and I say my class dunder my adder. Get an attribute error because it is private. Okay, so we got a couple more minutes left in office hours. I do want to talk about inheritance. Probably won't talk about it all today. So let's lay out the groundwork. As I said before, very rarely will you be having to make custom classes from scratch. What is common is for you to build upon what someone else has already created. This idea of standing on the shoulder of giants, right? Now, this idea of not having to reinvent the wheel, we want to improve on the wheel. So let's define a very simple class. I'm going to call this class pet. And I'll talk about a case that doesn't, very simple, and then we can expand on it. I seem to get an error when I run the grader. Do let me know what that error is. And let me check something really quick. Maybe there is a mistake in our code, but do let me know what that error is. And I create a pet, and let's say the pet has a name and it has an age. And let's say the pet has a method, and we'll call that method I don't know, we'll call that method walk. Okay, we'll call that method walk, and all it does is, let me just say speak. How about speak? We give it a message, and it just prints out that message. Okay. Invalid syntax, I forgot about. Self, there we go. And I can create objects of this class here. Pet, and give it a name. I'm gonna call it my, I'll call the pet Pumpkin. And the message is, no message, age, 5 years old. And I can call speak. I can talk. A very simple class. Create a pet objects from this pet class. Give it a name, give it an age, so there are 2 attributes. It is a speak method which prints out a message. Now we want to define a dog class. We want to define a dog class. So, but the dog class is going to have pretty much the same functionality as our pet class. It's going to have a name, it's going to have an age, it can also speak. However, it can bark, it can roll over. It has additional functionalities to our generic pet class. So I could copy and paste and say class dog, speak, and then say def bark, and that just says print bark. And maybe it has a method called rollover, and I don't know, it prints I rolled over. Or maybe it rolled over means, maybe this will have a attribute called self upright is, let's say, true, and then let's say it has a method called sit. Method called sit. That what it'll do is it will change upright to false. All right, Kinjal, glad you found the mistake. Glad it worked out. Now my question to you is, what was wrong with what I did here? What was wrong with what I did here? I created a class called dog. I copy and pasted my pet and just added the additional functionality. What did I do there that was, yes, it's gonna run, it's gonna be correct, but it's probably not best practice? What am I doing here that is not proper? Yeah, there's a lot of repetitions. Exactly. I am repeating myself. I'm copy and pasting. I don't want to do a lot of copy and pastes. So yeah, we can also use the speak method of the previous one. So as you guys kind of are formulating, what I've done here, while will work, isn't the best approach. I'm repeating functionality. So maybe instead what I gotta do is, when I create this dog class, I should inherit this template and then add the additional functionality. So there is a better way. We will talk about that next week, because inheritance, like I said before, when you move on to Unit 2, you don't want to create machine learning models from scratch. What you do instead is, if you want a modified version of a class, you inherit the template and then you add your additional functionality. Don't reinvent the wheel, improve the wheel. And you're going to see that a lot in Unit 2. So I do want to emphasize concepts in Unit 1 that are important in Unit 2. So with that said, guys, we'll finish this inheritance next week and perhaps make progress on the next mini project. So with that said, guys, take care, have a good day, and have a good rest of the week, and see you all